Okay, what's up? I'm writing about quantum numbers, and this is the third time I'm making this video, so I'm going to try to do it pretty quickly. There it is, quantum numbers. Okay, so basically it's based off of Schrodinger's model, which allows an electron to occupy a three-dimensional space, and it has three coordinates or three quantum numbers. These quantum numbers are n, the principal quantum number, L, angular, and M, which is magnetic. Magnetic describes the orientation of an object. The angular describes the shape of the orbital, and the N principal number describes the size of the orbital. Now, to put this in, to go into more detail of this, let's go into the N principal quantum number. Acceptable numbers for this is anything except for 0 or negative numbers. So n could be 1, 2, 3, etc. If n equals 1, then the sphere or the orbital could look like that. And if n equals 3, then it might look much bigger, like so. Now, if we go into the shape of the orbitals, basically, it's going to look something like this. Sorry, that's bad. The L orbital can be anything from, basically the general rule is n minus 1, and it can be 0. So when L equals 0, it's going to be a sphere like this. When L equals 1, it's going to be more of a dumbbell shape. And when L equals 2, it's going to be more of a clover shape. Now, one thing is that L can be greater than 2, but it won't have a specific shape because it's just too complicated. So when this happens, it's going to be called an F orbital right there. I'll put it down here, F orbital. A clover right here is going to be a P orbital. A dumbbell is going to be a D orbital, and a sphere is going to be an S orbital. They can each hold up a certain number of electrons as well. So an S orbital or a sphere can carry up to 2. A dumbbell and 1 orbital can cover up to 6. A P orbital or a clover can handle up to 10, and an F orbital, which has an indeterminate shape, can go up to 14. You'll be going more into detail with this with electron configurations. Now, for magnetic numbers, this is quite simple. Magnetic numbers is basically plus L to negative L, and it can be 0 because if L is 0 as a sphere, then M would just be 0, like so. And if N was 1, then it could be anything from positive 1 to negative 1. And that pretty much covers it. Thanks.